The aviation sector contributes to around 2% of the world's total CO2 emissions. Despite being considered more challenging to reduce CO2 emissions compared to other sectors, there is an urgent need for robust measures against global warming. The key to solving this issue and achieving carbon-neutral air travel lies in sustainable aviation fuel, known as SAF. NEDO, the new Energy and Industrial Technology Development Organization, has been engaging in research and development for the practical application of new fuel using wood and microalgae, known as SAF. What is required of SAF is that it is a biofuel derived from biomass grown through photosynthesis to absorb CO2, while also allowing the use of existing infrastructure and aircraft, just like petroleum-based fuels. This requires the production of high-quality liquid hydrocarbons. One of the materials chosen for this purpose was algae, commonly found in and around water. It doesn't compete with food sources such as soybean oil or palm oil and has the advantage of achieving high production yield per unit area. Botryococcus in particular is a genus of algae known for its ability to produce hydrocarbons directly. It produces huge amounts of oil inside cells that are clustered together like bunches of grapes. The oil contains a hydrocarbon known as botryococcine. The algae are harvested and dried to make dried biomass containing this oil, which burns vigorously when ignited like this. A practical problem with using Botryococcus was that it was slow in its growth. But a fast-growing strain of the algae was discovered in Japan, leading to research in using it to produce SAF. Efforts to realize stable production in outdoor cultivation tanks, boost growth rate and size, and improve the buoyancy of the algae for easier harvesting through continued selective breeding led to the development of technology for producing aviation-grade fuel from cultivating it. Meanwhile, research was also carried out on biofuels made from wood. This plant was constructed to carry out demonstration experiments. Waste wood brought here is fed into this oxygen-blown biomass gasification furnace from below. The waste wood moves up the furnace as it is incinerated at high temperatures, producing hydrogen and carbon monoxide gas. Technology and know-how cultivated through gasification technology for coal and other materials is used in this equipment. It achieves stable gasification even when using waste wood of varying quality. This gas must then be turned into liquid fuel. Microchannels loaded with an FT synthesis catalyst are used to do this. Continuous catalytic reactions in the microchannels convert the biogas into a liquid hydrocarbon consisting of long chains of carbon and hydrogen. FT synthesis is a technology used in various processes, such as at natural gas liquefaction plants. The goal was to develop highly efficient technologies for use in SAF production. This is how a transparent, colorless liquid biofuel like this can be produced from wood and algae. This biofuel is then turned into SAF by removing impurities through distillation and blending it with petroleum-based fuels. Current SAF standards allow up to 50% blending of the biofuel. The future goal is to aim for flights powered by 100% SAF. On the other hand, aviation fuels are subject to international standards, which must be met in order for them to be used in aircraft. However, it was confirmed that the primary components and trace elements of SAF all conform to the specified standards. Combustion tests were also carried out using a gas turbine combustion model to analyze its combustion characteristics and exhaust gases. The results indicated that its combustion performance was equivalent to conventional fuels, while demonstrating high environmental performance by emitting considerably fewer microparticles such as soot. The model engine was also used to take outdoor measurements of engine thrust and fuel efficiency. This is how the technologies of a variety of domestic companies and research institutes were brought together, leading to the integrated production of SAF and its delivery to Haneda Airport in 2021. Actual passenger aircraft are being refueled with SAF made from wastewood biomass and microalgae. Various checks proceed smoothly under the watchful eyes of those involved, and an aircraft finally takes off. This is how the practical application of the next-generation aviation fuel, J-SAF, was realized, paving the way to carbon-neutral skies and leading to net-zero air travel.
NEDO